we have a stall. So we have many participants at least, and each company is going to present their advancements in technologies today, first half. So today we have 5 presentations in this Expo from Ecom Ecotech Industry Private Limited, which Dr. Harsh will talk, and then Mr. Nishad Mittal from TFI Instrument India Limited, India Private Limited. Then we have Mr. Prakash Kata from Vasti Instruments Private Limited. Then we have Mr. Nishi Java from Poriva India Private Limited. We have Mr. Lee Sang Min from Caltech Incorporation. So these are all 5 presentation, 30-minute presentation we have. And I just want to say that the aim of this expo is to, first time we are organizing this year expo. So, you know, in science and technology, every year we have many innovations. So most of the time we want to advance in our technologies so we can measure more precisely, and also, you know, without or less human error. So this is the motto of research and technologies. So many industries, you can see companies, they made a lot of good research in last years, and they advance their technologies. So I would request that the companies, we can showcase their advancement, their technologies here. So in this, I won't take much time, and I invite first Dr. Harsh Dixit for his talk. So Dr. Harsh, please.
Good morning. First of all, thanks, sir, for giving us a chance for just to showcase our few of the advancement which we have done in the recent years. I'm just starting the presentation. तो लगा दीजिए वहाँ से सेंड करेंगे कहाँ से वहाँ नहीं है उनका कैसे ये बिलो कॉलर माइक लगा देगा, स्टेज पे चल के बोलना होगा, पूछ लेना, ठीक है। बैटरी देख लेना जगन्नाथ जी। जगन्नाथ जी बैटरी देख लो अर्जेंटर का, ठीक है। So, I'm just starting from light introduction about the Accord India. Most of you may be quite not aware about the Accord. Basically, it's actually according to the motto of our organization is to get the true sustainability. In the Accord, basically, we feel that true sustainability is balancing what we need today to meet as a society with the meeting the needs of the future generations. It is a delicate balance between the growth and the conservation, exploring and the preservation, and being open to the new possibilities. So we at AdMet, our main focus is to balance and to keep provide the creating the environment of the possibilities. We also believe that the human progress is all about the finding the right balance.
डाउन है
Clearly significant in our globe also. We believe in the meaningful data, basically, to take the right actions. So kind of data which is produced through our number of equipments, samplers, devices for the acoustic, air and particles, emission and gases, vibration, alignment, conditional monitoring, the number of kind of data, whatever is available, produced to the industry, we have to capture it and turning into the insights so that the actionable insights can be reached and the right balance can be achieved for the sustainability. Economy is working in the 5 verticals. First one is the industrial reliability, just to increase the productivity of the industries, then emission and the process to achieve the environmental compliances, ambient monitoring to monitor the air pollution data, and the protection to saving the life of the protecting the soldiers, sites, and the battles. So we are also in the field of the defense. And last one is the design, just to get and achieve the effective, robust, and noiseless products. When we are talking about the emissions and process, I'm only taking care of the 2 parts, emission and process and ambient and monitoring. So it's a continuous emission monitoring for the opacity and dust and the particles. We have another verticals of the tunnel sensors for the visibility, airflow, and the luminescence. Approximately 600 monitors we are installing around the world every year, and approximately 240 tunnels right now we are having in our portfolio for the monitoring of the data. When we are talking about the ambient air monitoring, we are having the applications for the noise and vibration, meteorological monitoring, gases and particles and emission for the outdoor and indoor air quality, the blast monitoring, the dust and the fence line monitoring. A number of applications are available. And approximately 3,200 plus monitors every year we are producing. And around the world, we are having approximately 1,200 stations for which we are having operation and maintenance contract. When we are talking about our international footprint, according to the data of the 2020-21, the annual turnover is approximately 130 million euro. We are having approximately 1,850 employees around the world and 220 partners as distributors. Economy is having 9 offices in the 9 locations and the 28 offices, including the US, Asia, and Europe. For the environmental products, we are having 6 plants, Australia, India, France, Sweden, UK, and USA, and 5 R&D centers around the world. Yeah, it's a very important slide basically because economy is not too much popular in India. So the birth of economy happened in the 2011. It's a French organization. With the acquisition of 4 quite good market players of that particular time for the Metawave Foundation for the working in the field of the vibration in engineering, 01 dB for the acoustic and the noise, then the defense threat system, including the Brazilian subsidiary of that, and the Areva, which is working in the field of clean nuclear energy. So since 2011, the acquirement taken place. Then 2014, we acquired the fixture laser for the shaft alignment, then vibration, fiber line integration for the shaft alignment. Till then, you can say it's not an environmental related company. This is particular 2015, but in 2017, we acquired the Ecotech Australia, including the Indian and German subsidiary. So we have added the dust pollution monitoring equipment and the gases polluting monitoring equipment in our portfolio. In the 2019, we have acquired the air monitors, Danoptics, and tunnel sensors, UK-based organization. Then 2021, we have done the 2 acquisitions for the reliability point and the US organization, and the second US organization for Met1 Instruments in the 2021. Okay. If we are talking about the Indian operations, we are having a one manufacturing plant in the Indore, Pithampur, near to the Indore. It's this particular plant is started in 2015, and it's 100% owned subsidiary of the Ecom India. And we are proud to say that's till today, this is the only manufacturing plant in India which is having a USEP approved facilities. So we are manufacturing all the gas analyzers for the SO2, NOx, ozone, carbon dioxide, carbon monoxide, ammonia in our Indian plants, and we are exporting around the globe from here. In India, if we are talking about, we are having 4 office locations in the Indore, Pithampur, Delhi, and Hyderabad. The second plant, you can say it's a plant, the manufacturing plant is in the Vadodara. It's for the remote diagnostic center and the repair and calibration center. So we are proud to say that we are made in India and we are made for the world. If we are talking about the environmental portfolio, then we are having 4 divisions in our environment section. Particles and the metrology, which is basically products related to the metal instruments. Then gases and aerosol, basically is for the ecotech products. Emission and tunnels for the jan optics and tunnels, and the noise and vibration for the acoustics for 0.1 dB products and the vibration alignment. Now it's an important part which starts. So if we are talking about the ambient air solutions, we are having different applications for the gases, the research and scientific particulates, and the data and softwares and the blast monitoring. For the ambient air, we are manufacturing approximately all gas sensors. All these gas sensors are approved through the international organization for the ozone, carbon dioxide, NO2, CO2, NOx, SO2, ammonia, H2S, total reduced sulfur, and the total sulfur. All these gas analyzers are approved from the approximately all the international organizations like US EPA, EN approval from the TUB, and EN approval from the MSATs, and the number of other approvals. For the calibration point of view, for the calibration, to do the calibration of these gas analyzers, we are having a number of options for the Cyrus Cal 300 for the ozone generator and the compact reference photometer, then dilution calibrator, along with the GPT, the gas phase titration, basically required for the NOx analyzers calibration, as well as the ozone analyzer calibration. Then we have a Cyrus Cal 3000 with having all the internal ozone generator and the reference photometer. So these are the number of options we are having along with the GAO generator. To provide the integrated systems, we are having we are basically manufacturing the sequence stations, then SEMS, then the trace and background and air quality monitoring systems, then the total solution package and customized design. One example of the customized design is that recently we have supplied the 2 sequence stations at the Rohtang Pass on the Atal Tunnel, basically. So the both end of the Atal Tunnel is having the sequence station which is installed by us. And it's a very special sequence station because in India, most of we are having tropical countries. So almost every sequence station is having a temperature controlled inside. So Atal Tunnel, there is a very different kind of environment. Almost every time its environment is below the 0 degrees. So we have provided such kind of systems that can work in that particular environment. So we can proud to say that we are also having a number of different applications according to the customer's need. Then comes to the different research related equipments, just like an afflometers. It's this particular equipment is used to report the integrated and backscattered coefficient that can actually measure the influence of aerosol scattering on the Earth's radioactive balance. This particular equipment is much used by the ISRO organization and the remote sensing organization just to get the data for the aerosol scattering. Then we have also recently launched the Aurora 4000. This is the first commercially available polar afflometer around the world. Then another equipment is basically aerosol conditioning system. This this is a unique system basically, which most of the companies are not having. So this particular equipment is used to study the hygroscopic properties of the aerosol particles and offering the insights into their effects on the Earth's radiative balance. So in this particular thing, that's two different systems are get used. So one is for the wet analysis and one is for the dry analysis. Another difference equipment is the trace gas and isotope analyzer. Basically, it's a spectrometer. It's a FTIR spectrophotometer, and it can measure multiple greenhouse gases like ammonia, N2O, carbon monoxide, carbon dioxide, including the trace carbon 13 and the oxygen 18 also. So, and does not require the frequent gas calibration. When we talk about the particles and the particulate matter and the dust monitoring equipment, all the equipments are divided into 5 categories. First one is the non-regulatory, then the regulatory monitoring. That means it's FRM category equipment. Then the clean room monitors and the control room monitors. Then indoor air monitoring and the spatial particulate monitors are the samplers. So when we're talking about the non-regulatory supplements, it also quite famous as the sensor-based equipments. So these, according to us, basically, these kind of monitors and the particle counters that samples the air, ambient air for the air quality indicators, not reflected, distributed to the federal, state, and the local regulation. These kind of monitors are only giving the data which can supplement the local data to fulfill the regulatory gaps. So for that, we are having a number of products basically. So first one is the e-sampler of the dual ambient and PM particulate matter. So it's having a real-time data as well as the samples can be collected on the filter paper also for the further analysis and the monitoring. Then the remote dust monitors, it's a nephelometer category dust monitor. Then the portable simultaneously particulate profiler, then the network particulate monitor. So all these are the non-regulatory supplements in formal products. When we are talking about the FRM category or the regulatory monitoring products, then BAMs comes. So if we are talking about the BAM, then it's a BAM 1020, which is installed inside this ecosystem. It's working on the beta version technology. And we can proudly say that we are having approximately more than 20,000 installations in India right now for that. And when we are talking about the outdoor air monitoring, then we have 3 options. First one is the EVAM portable, then EVAM plus, then EVAM 1022. So EVAM 1022 is having the US EPA approvals for the both PM10 and PM2.5. We are also having one more Spine BAM, which is before the Metman acquisition basically. So it's also having the same specification. Okay. Now we have except the BAM monitors, we also have some samplers which are already US EPA designated. For that, we are having approximately 3 monitors. First one is the EFRM DC. It's a simple PM 2.5 sampler working on the flow rate of the 16.7 liter per minute. And all the FRM and this 40 CFR Part 50 related requirements. Then second one is the E-sequential FRM. It's also an FRM category PM 2.5 sampler, but it's having a cartridge system which can hold up to the 16 filter paper. So manpower is not required to change the filter paper every time. So it's automatically according to the user program, the filter paper is get automatically changed and it will be kept in a second cartridge. So after the 15 days, a person can go and collect all the filter papers. Then the third one is the very special sampler is the SAS sampler or the super SAS sampler. That particular sampler is used for the speciation, chemical speciation sampling. So it's having option for the 5 inlets and the 8 inlets. And with each inlet, we can change the configuration. We can use PM 2.5 also, PM1 and the PM10 and the SPM. That's 4 options are available. So at the simultaneously, we can do the monitoring for the different parameters. So the dust will be collected on the filter paper and then it can be used for the chemical speciation. Then some more samplers we have, just like a high volume sampler. It's also for the PM10, PM2.5 and the TSP. Then puff sampler, XAD samplers, then the mega volume sampler. It's a mega volume sampler is used for the more quantity of the dust if it is required for the trace metals basically, and some other trace elements. Then the microvolve sampler, and we proudly say that NPL is using the microvolve sampler in their few of the studies. And then the calibration plates. Then some are the clean room monitors and the control environment monitors. So basically, these kind of monitors are used in the different industrial application for the semiconductors or the biotechnology, then the pharmaceuticals, electronics and optics, and the military, aerospace and medical and food packaging kind of industries. So this particular these kind of monitors are for 21 CFR Part 11 compliance and working on the compliance with the ISO 21500-01-4. So it's having very sophisticated, and that we are having a number of options for the 10, 2.5 and PM1. Then some more clean room monitors are the handheld particle counters. So all are having a different specifications. Then the monitoring of the indoor air quality. So for that, we are having some benchtop particle counter. So it's once again a flow optical sensor is combined with the purge air system to ensure the accurate measurement. And it's also having a laser optical sensors to detect and measure the particulate concentration up to the 100 milligram per meter cube. And it's also having the options for the TSP, PM1, PM2.5 and PM10. It's a battery operated system, so it can work up to the 10 hours on the battery power. Except this, these three monitors are also available, and that's AeroSet 532 handheld particle monitors are having the both kind of facilities that it may have the particle count as well as it can convert all the particle count is to the mass numbers also. So it's a 6-channel system. So TSP, PM10, PM7, PM4, 2.5, and PM1 is the option available. Now, few monitors we have for the black carbon. The first one is quite famous, so I have not kept in this particular slide. It's a accelerometer, basically. So this particular model, which I have shown in this particular slide, is a 2-channel system. So it's a first two wavelengths are there. First one is the UV 370 nanometer, and second one is the near IR 880 nanometer. So the filter tape can work up to the 6 months on a single filter paper, and the flow rate is only 2 liters per minute, and it's a portable system. So at several places, this particular equipment does get used to get the real-time black carbon monitoring. Then another one is the very simple portable carbon monitor. So it's single wavelength working on the 880 nanometer near the infrared, and the flow rate is only a 1 liter per minute. So it can also work on the solar power. So we can place it on the remote places, and the filter paper is need to be changed once in a 6 months. So it can be used on a remotely. Now, there are few systems which are used for the aerosol research related systems. The first one, once again, is the nephrometer, a different model. This particular Aurora 1000 model is to be used for the aerosol light scattering, visibility, and the particulate monitoring. So it's having 3 options, but only one wavelength is available. So the wavelength of the 450 for blue light is used for the fine and ultrafine particles. 525 is used for the visibility, and 635 nanometer is for the larger particles. Another one is the 2000. It's a correlating nephrometer, so it measures the aerosol light scattering as well as it can give you the particle concentrations also for the PM2.5. Then some mining related equipments like the dust rover. So it's a vehicle mounted dust monitoring system. It is moving around the mining area and giving the real time reading on the maps. So such kind of maps are there on the dashboard, and we are having all the data while moving the complete mobile system. Then the integral radar, the second option. So it's a holistic 3D diagram system is there. So it's a completely 3D monitoring system. The radar is indispensable operation tools for the companies to enhance the workplace efficiency. So it can measure the emission sources and the movement and the trajectories over entire scanned area, and the ranging from the few hundred meters to the 12 kilometers in the diameter, in the radius basically. So 24-kilometer diameter we can cover. So it is equivalent to the 50,000 individual dust monitors if we are using. So we can manage all the data on a Google map. So it's having two kinds of scanning system. First one is the radial or the plant position indication, which covers the complete 360-degree rotation on the target, the partial segment of scan, plus the wind speed and wind direction. So all the particulate matter transportation we can measure on that. And the vertical for the height indication is to determine the lift up of the ceiling height of the dust plume dispersion. Then some other software systems we have, but I'm just skipping that particular part because of the limited time. The first one is the data acquisition system, then the asset management softwares and the data validation and the reporting softwares. Then there are some meteorological products, just like a ready weather data to desktop weather station. So it's having complete weather station. Then one unique system we have for the AQ Eagle, we are saying that it's having option for the particulate concentration for PM10, PM4, PM2.5, and PM1, and including as well as the data related to the weather parameters. And all this data is available on the site map where the AQ Eagle is located. So we are having the complete data of the wind speed, direction, temperature, pressure, as well as the PM concentration and the real-time data. It's also a ready-to-use system. Then there are a number of weather sensors. The second parts is the diagnostic system is used for the SAMS analysis. We have opacity meter, particulate monitor, dust monitor, the marine monitors. It's a quite new kind of concept is came. It's used in the ports basically. So which particular ship is more polluting that particular port, we are trying to find out. And according to the international laws, which are applicable nowadays in India also, so that particular ship get be penalized according to that pollution they are emitting during the it's parked in the ports and the tunnel sensors. So we are having a single pass opacity meter, double pass opacity meter, and the particulate monitors. And the tunnel sensors for the number of gases pollutants, then the dust pollutants, and the luminescence. And we are having a number of installation in India also for the tunnels, basically. And we are proud to say that we are the global leader in that particular tunnel sensors manufacturing. Then the last, we are having a sensor-based air quality monitors. Its brand name is Konark, basically. So the number of esteemed users are there. Unfortunately, in India, it's not much popular, but in the worldwide, the WHO, then the World Athletics Organization, then Intel, a number of places it's get used. It's also tested by the AQ program, and a very nice results are there. And this proves the accuracy of our sensor-based systems. Then a few products of the acoustic, basically a sound level meter for the class 1 category, then the real-time monitoring stations, and the airport noise and flight monitoring systems. And I'm very happy to share that at right now in the last 5 years, whatever noise monitoring terminals are installed in India are supplied by us. And within Delhi, we are having a 26 noise monitoring terminal, which are used by the DPCC. And so data is publicly available. And regarding the airport noise, we are having number of installation in the airports, basically. So they are the few examples for that. Thank you. I hope I have finished it within the time.
Dr. Harsh, I think you have a very good presentation, and also you can see that we have a wide range of instruments. So of course, it's difficult to ask technical or scientific questions in the technology related. And probably we can visit stall and see your instrument and discuss in detail. But if someone having some specific question, can ask one or two questions, technology and scientific questions. Do you have any questions from audience? So
Thank you.
yeah, I thank again Dr. Harsh, nice presentation.
उसके प्रेजेंटर है आपको पीपीटी लेके मुझे शेयर करो।
Now we have a second presentation from Mr. Nishant Vittal, PSI Instrument India Private Limited. So I invite Mr. Nishant for his presentation.
कैमरा ऑन करो।
Hello, good morning, everyone. So myself, Nishan Mittal from TSI. So today we'll be talking about some of the instruments that we supply from TSI or we make a service available. But before that, also we'll be talking about some of the trends that are happening globally, and that if possible, we should be trying to follow in India so that we get some better results. As we are now having a very big problem of pollution in India, and how other countries are solving and what we should be doing it if we want to solve it. So
एरो की से करना वीरेंद्र
So this is the overview of my presentation. So first we will be talking about what TSI is. Then we'll give you some overview of, what has changed after COVID. Before COVID, there are many different things, but after COVID, there are some awareness, some other things happening. And then we'll give you some brief information about the global networks of aerosol that's happening. And then we'll talk about TSI solutions. So TSI, this is our headquarter office in Shoreview, USA. And our office is in Minnesota. Okay, so it's more than 60 years old company. We have global presence, all Asian and European and other countries, more than 1,000 employees. In India, we have offices in Bangalore. So we have a direct office. We are not working to any channel partner or distributor. So we support our customer for any sales service or any other application point of view. So we support directly. In TSI, we support multiple domains. So we have multiple areas where we do supply instruments. So one is the environmental, which is very known. Then we do have services in healthcare. Then we have instruments for accuracy instruments or accuracy testing. Then we have for lab. Then we have for field mechanics. Multiple domains classified, but today, since we are talking about the air quality, we will be talking more about the environment. So aerosol, usually, if you see this is what we have as an aerosol. So earlier we used to measure only PM10. Okay, so PM10. PM10 earlier we used to just measure here. Okay, later on scientists found out, okay, that PM2.5 is more harmful than PM10 because PM2.5 can reach up to here. But now there are studies coming up that even the ultrafine particles smaller than this are very harmful. Why they are harmful? Because already we are at the end of the this structure. Because these ultrafine particles, they can pass through this and they can mix to the blood directly. Okay, and then there was one study where the metal traces are found in the human brain. So that type of ultrafine particles are very harmful because they are not easy to detect, and once they reaches to brain or any other organ, they give a very big damage. So that's why there also we need to know what type of ultrafine particles are there sources are going on. Okay, so before after COVID, now before COVID we are not much aware about the mask or air quality, we are just relaxed. But now after COVID, now we are in a public, a general public is also very much aware how a pollution affects, what happens if they put on a mask, how their house should have ventilation. So people are learning and trying to search themselves also that how they can reduce their pollution levels. Okay. Now in respect of aerosol or the aerosol research, now scientists are also doing more studies on bioaerosol, how they are behaving in a normal air or the pollution air. Now if you see this COVID, in Delhi, we had a lot of pollution. So maybe because of that, it has a larger impact in Delhi, whereas in other city where we have a less pollution. So there are studies going on to find out what kind of pollution rules are happening in the spread of this type of disease, because this is what, but we don't know what comes in the future. So preparing for that is very important. How the aerosols are moving in the different type of atmosphere and how they are affecting human health. So those type of research are now, people are focusing more. Indoor air quality, people are concerned in air indoor quality where people like office, a big large office or residential properties or hospitals. There earlier no one cared, but now people are caring about what is the indoor air quality, how is the ventilation. In the hospital, like we have multiple departments, one is a cancer department, one will be some throat infections or some other thing. So now if their ventilation is not proper, so there are chances that the disease may transmit from one department to the other, or the visitors to those patients, they may also get affected. So those type of studies are happening, how these things are affecting the aerosols and filter media. Now this is the industry. Filter media is the industry where they are trying to see that our employees who are working from like morning to evening, midnight, closed room, how they get a fresh air. Usually it's a closed loop. So we get the clean air without particles, but it also reduces the oxygen. So if we see our oxygen blood level in our office sitting from morning to evening without opening the doors, by evening we'll start getting a headache because we'll have less oxygen in our blood. So now companies are trying to do a regular real-time monitoring of all these parameters in their office so that they can maintain their HVAC systems properly. This is the one side. Other side is the manufacturing companies who are making filter media. They are also trying to find out filter medias which can run for a very longer time, give a very good efficiency. But here the policies that we make from the Indian government, those are also playing a very crucial role. There are policies in place, but implementing them is another challenge. So if those comes in, we know that what type of filters now. Everyone can say they know we are making a filter, but they should pass some standards. If those standard filters are used in the factories or in the hospitals or any other place, it will surely make a good environment for the people to live in. Also, we spend a lot of time in car. We always use closed, we put on AC, we close the cabin. Inside the car also there is a pollution. We usually see that, we feel that there is no pollution, but actually there is a pollution inside the car also. So there are studies happening for that also, and the companies are also giving those type of features. So they are trying to incorporate those type of features to improve the air quality inside the car. Actually, there is a standard for that also. There are very less people who knows about this type of standards in India, but there is a standard, especially how to maintain the cabin air quality inside the car. So those type of things now slowly coming up. People are thinking about it. Companies are thinking about it. So those things are happening after COVID. Before that, it was not there. So now we'll talk about the aerosol network. So we'll be talking about the networks outside of India. Inside India, what is happening, we always know. So what is happening outside of India, we'll just give us some brief about that. So this is the first network, AeroNet. This is started by NASA, but they use mostly satellite-based monitoring, and this is, you can see their presence globally, and they take a lot of data all over the globe, and then they use satellites to monitor what is PM level happening. But along with this, they are also having the instruments at the located at multiple locations, which are ultra fine monitors, because satellite data cannot give data more than of a smaller particles or ultra fine particles. So these networks, they are also using a data of ultra fine particle monitors installed on the ground. So next, the latest one is Actrix network. This is very famous these days because this one, it is taking the data from all the different places. This is using different instruments. Plus, it is also giving a recommendation what type of instrument you should use, what type of methods you should use, how you should analyze the data. So they were given the complete list, what type of instrument to be used, how they should be used. Most of the time we buy a good equipment, but we don't know how to use it properly. So the data we are getting out of it is either biased or not correct. But this list help us to find out the correct way of how to use the instrument so that we match to those type of data and network. So this is a very good, right now going around. The next is China. China, we know in 2013 or 12, they had a lot of pollution problems, but now we see they are improving a lot. So why they are, such a big difference between India and China? China, as a space, they are very big, but still they are able to control the pollution as compared to India, we are going in the other direction. So how they are doing it? So they have created a super stations. Normally people say that we have a monitoring station, but China is creating a super station. What is super station? They are, other than PM1 or 2.5, they are precisely monitoring up from like 10 nanometer, 20 nanometer, those type of ultrafine particles. What is their source? How they are coming? How they are reacting to their environment? They are doing this 24/7 monitoring all the time. Those are type of the data which helping them to find out the sources, controlling those sources, creating policies and implementing those policies strictly. It's not just create some policy and then leave it. No, they put a penalty whoever is not going with the policy or making some policy on those things. So that type of thing is what China had did strictly to come down the policy. If you see, this is like how many stations they have. If we put an Indian picture like this, we will have a lot of gap in between. But in China, they have put a lot of stations doing real-time monitoring and long-term monitoring with the proper instruments, with some advanced technologies also. And then comes the portable sensors. So these days we are talking a lot about the low-cost sensor. I'm not saying it's a low cost because low cost can vary from any range to like 7,000, 10,000 to any number. So we'll talk about the portable sensor. The portable sensors, there are multiple ways to use. Right now we are using only like, we put some on some place and then we start monitoring it. But there are other ways of doing it or other ways that how people across the globe, they are using it. So they put on the houses because houses are the one place where we spend more of our time. And that is the place where we'll have, while we are doing a cooking or something, there will be some pollution out of it. Then these glucose sensors are installed on the moving vehicles because moving vehicles are like a taxi. They are going around the city in multiple type of locations. Some locations will be highly polluted, some will be less polluted, but they will give you an overview of what is happening on that part. Okay, then there are some low-cost networks which will be installed by the government. So they handle it. So this data is not like, to make policy, but this is to understand what is happening around the city, where we are having more pollution, where we are having less pollution. Then we find an area where we have a lot of pollution, then we go with the full fledged system, install there, find out what are the sources, what are the reasons, then solve it. So low-cost sensors is basically getting a lot of data to understand and find out what's going where. Because we can't put expensive equipment on the places or on the cars or the houses. But low-cost sensors or the portable sensors, they're small, less in cost, even if some get damaged, it's not a big problem for them. Now, next is in India, also now it's improving is that mobile monitoring. So now there are vans which have all the high-end equipments installed inside. If you see this one has meteorological parameters, optical instruments, real-time mass measurements, and size distribution measurements, chemical measurements, everything is installed. And this, if you see, this have a probe here. So it can, follow a vehicle, a truck or something to understand how they pollute when they are driving, because sometimes they are at a traffic light, but they don't switch off their engine. So how much they are polluting, how much when they apply a brake, there is emission from brakes also because of rubber. So they can monitor that, what that is happening, how they are having, if there's a jam or traffic situation on the road, how that pollution is. So those type of things you can measure from this. Similarly, this probe can be converted and attached to the back of the van. So here you will see that what is happening behind the vehicle, but mostly that is avoided because that can also affect, like you will be measuring your own pollution, van pollution. So multiple ways people are doing, but if you get this type of vehicles, or if we many people are not doing, how we get the data is like this. So in the graph you can see from starting point this to this, how the concentration is varying from different locations. We can find out. Once we know where we have a higher concentration, then we can stop the van here and find out more what is happening there, what type of pollutions are there. So those type of things are possible. These things, if we have this kind of portable solution, then only it's possible. Otherwise, we know instruments are expensive. We can't take always out and carry in a flight because of transportation, they get damaged and everything. But if institutes has a maybe one van for each institute or something like that, then whatever the equipment they have, they can put in the van according to the requirement. They can go. IOCL is the one example. They have this type of vans. So what they are using for? ISL is an Indian Oil Corporation, but what is their use in the air quality? They are using these wells at the petrol pumps. So when the petrol or the diesel that comes in a container and get transferred to their tank on that particular petrol pump, there are vapors that are moving out, and the nearby residents, they are complaining about those fumes or the particles or whatever it is coming to them. So now ISL is using these wells to monitor what type of pollutions are coming out when the petrol is transferred and how to avoid it. That's just one example, but there are multiple ways people are doing it. Other thing is like now this one. So we have an instrument kept in a car, and you go on the road, and this is a truck where we are following it. And you see whenever there is a pollution high, like they suddenly accelerate the vehicle. You see this orange color thing, high concentration. So we can find out what are the reasons why now in foreign we don't have a traffic like us. So they can easily find out if someone is accelerating without any reason. Okay, whether they are allowed to do it or not allowed to do it. So those type of things they can find out and make a policies accordingly. So now we'll come to TSI solutions. In TSI, we have multiple solutions of different range or different sizes related to environment. We have other solutions, but we'll be talking about mostly in the environment part. So first, we'll be talking about the scanning mobility particle sizer, which is one of the gold standard product known worldwide. Then we talk about the condensation particle counter. Then we have a real-time mass measurement device, then aerodynamic particles, then PM monitors, IAQ monitors, and portable sensors. So first is our TSI SMPs. So this is one of the gold standard products used worldwide. Many people use this instrument to calibrate their equipment or some other things. The NIST in the US, National Institute of Standards and Technology, they use this instrument to make particles of specific size. Let's say they want particles of 10 nanometer. This instrument is used to generate the particles of 10 nanometer and store them and then later on sell as a standard. So this is one of the major equipment which is used. Even in India, we have multiple installations of this unit, and people are using in different locations in different ways. One of this unit is installed in Siachen also. Siachen, where there is no human activity, but still we find a lot of pollution there because the pollution what we generate here with the air, the nanoparticle that transport over there, and those are captured in this particular machine in Siachen. It's near to the Siachen base camp. So it can do a measurements from starting from 1 nanometer up to 1 micron in real time. And this is the one example how other people are using. So by the roadside, they have kept these instruments in some racks at different locations, 1, 2, 3, 4, and there's one switch there. Now they understand in real time how the distribution of the aerosol changes with the distance. Either the nanoparticles are transmitting over there or the larger particles transmitting over there. How the chemical compositions of those particles are changing. So those all things can be, they are doing the monitoring here. This is just an example actually. Then it's a CPC. So earlier we talked about the networks, the different networks used across the globe. So the Actrix network, the latest one, they have recommended the CPC, Sense CPC to be used in the network. What is Sense CPC? Normal CPC, if you see, these are calibrated using PSL particles or salt solutions. This particular CPC or the Sense CPC is calibrated using silver particles. So using a silver particles, it is calibrated up to 7 nanometer detection, and this is specially designed for sampling system. In this, all the aerosol, whatever we feed to instrument, usually instrument will split the aerosol. Some will go directly to the exhaust and some will go to the optics. In this particular CPC, entire aerosol will pass through optics. So there is no missing of particles or no dilution happening, direct measurement of whatever is going inside the instrument. So this is the instrument which is recommended as per the network in the document I shown you the link. And this is the sampling system. recommended for this particular CPC. It's not like what we do in India, we just connect it to Bing and then it's done. No. In that particular network, they mentioned that how this CPC is to be used. If you need a diluter, like in India condition, we have a lot of pollution. Even in these conditions, they tell you how to use it. We have an effluent dryer in line to dry out the particles, remove the humidity. Then we have a diluter, how to do the dilution, and then do the counting. And this is how, the place they are doing outside monitoring and the multiple instruments showing where we are having the counting. So if this is in a particular application where fence line monitoring of the city is happening, so around the city, from which side the pollution is coming, they can find out easily. So this is a kind of network we are creating to control the pollution, to understand the pollution levels and how to control it. Then one of the other solution we have in DSI is the nanoscan plus OPS. Basically, these are two different equipments, but we can combine them to give you an entire range. So the nanoscan, which is a small portable equipment, can give you data from 10 nanometer up to 420 nanometer. It's based on the electrical mobility. And then we have optical particle sizer, OPS, which start from 300 nanometer to 10 micron. So if you combine these two ranges, we start from 10 nanometer up to 10 micron as a full range. And then we give you a specialized software along with this. So you get the entire data, plus you can do the curve fitting, because these two are different technologies. So curves will have some gap, but we do have a curve fitting option in our software, so that you do the curve fitting, this is a composite fit, and then you understand how the entire search. The best thing about it is, right now up to PM 2.5, PM 10, and PM 1. This can give you PM 0.1 also, because we have 10 nanometer, so it goes to a very low PM values. Next is our latest product, and one of the good product, I can say. This is the real-time QCM movie. Earlier there was an equipment called quartz crystal microbalance. So this is a little advanced version of that. So now we have a display, inbuilt data. We have a conditioning, live conditioning. So no matter what is the humidity outside, we can control the humidity specific to the instrument, so that the entire data what we receive is at one particular humidity, irrespective of Delhi or Bombay. We will have all the data at one particular humidity. In this instrument, we have 6 channels here. It's basically a moody impactor. But in each stage, we have installed a quartz crystal. So how it happens is, so we have quartz crystal, this also acts as an impaction plate. So when the aerosol comes in, so some of the aerosol, depending on their size, get settled over the quartz plate, and the rest of the goes to the plate. So on the top, we have bigger size particle. On the bottom, we have the smaller size particle. So as the deposition of the particles happen on the quartz plate, it is vibrating at a certain frequency. With the deposition, that frequency changes. The change in frequency is directly proportional to deposition of mass. Now, if you see, for example, the frequency first, it's vibrating at 10 kilohertz. After deposition, it came to 8 kilohertz. So the change is 2 kilohertz, and we do, okay, it's a 2 milligram, for an example. Now, after deposition, after using for 1 hour, 1 year or something, this quartz now start vibrating at 8 kilohertz because of some reason. But after deposition, now the difference comes to 6 kilohertz. Okay. Now, again, change in frequency is still 2 kilohertz. So it will give you the right mass. So no matter when you are using, it's always change in frequency, not the calibration. So virtually this instrument is calibration free. If some parts get broken or something, you just take it and put it there. It's done. You don't need to calibrate, because quartz crystal has their own properties which will never change. So that's why we have TUN as a standard product or FERM product, because it's based on quartz crystal. It is one step ahead. Plus, there is one more thing is that usually TUN, you measure only either PM 2.5 or PM 10. any one of them. These instruments can give you mass, real-time mass up to 45 nanometer. So there's no way that you can other way, like, you deposit 45 nanometers on a filter paper and do the microballistics. No, it is not possible because that weight is so less in nanograms that we will not be able to find out. But this device, you switch it on and in the real time, it will give you how much mass we have for 45 nanometers and 100 nanometer in different ranges. So here we have an example where the data for Moody is compared to TR for one particular channel, like PM 2.5. This Moody can also give up to 2.5. So now if you see the pink line, which is of Moody, the high resolution data. So this is like, why suddenly there was a peak, why there is, suddenly there was a period. So those type of things we can find out when we have an instrument which gives a real-time data with a high resolution. That's the benefit of QCM out there. And plus it's like kind of calibration free, so you don't need to worry about the equipment and all. And instead of waiting for 8 hours to get some data, it can give you like 5 or 10 minutes, same data. After this, we have environmental monitoring solutions. So we have different solutions for environment monitoring plus personal monitoring. So one is the environmental dust track. This instrument is used for outdoor monitoring. So you can just keep it on a rooftop or some outside building or some traffic jump or something. Just place it there and you get the data live on your desktop. This is one option to keep it outside. Then we have other instruments handle dust tracks. These usually are used for survey or by the consultants. They carry around these equipment in the factories, or you want to do indoor monitoring like this hall. So we have this equipment placed in some place, and then we know what is happening inside this hall, what type of pollutions or PM levels we have. That is one. And the last is site pack. This equipment is very useful for personal monitoring. So we know there are workers who are working directly on the machine, right? So pollution in this room might be different at this place, but if there is a machine running and the person sitting next to the machine, their pollution will be different. So this machine, this side pack, this person can wear on his bed, and then after 8 hours, we will know in the full day how much exposure he is having versus the normal air quality. So based on that, we can recommend him either using some ventilation or using some mask or whatever is required. But this instrument helps very much in that. These are also used in mining industries. And now we have a portable sensor we recently launched in worldwide. It's called Blue Sky. This instrument, as a part of portable sensor, can be plugged or hooked on any wall or something, and then we get the live data out of it. It gives, right now it's giving PM 2.5, PM 10 temperature, NDT, and the GPS. And the next version of this will be launching by end of this year, where we have the additional gases also. So this is how the data looks like. It has a website where you can have account. You can go and see all the data. It shows as the color version. If you have a high pollution, it will show in different color. If you have clean environment, this is today's morning data. What? Take a picture. And then you can see the data of today, a week, a month, or up to 3 months. All of this data is stored on the servers. You can download an Excel file and use the how you want it. And last, indoor air quality, other parameters, we have some sensors for that as well. So where we can do indoor air quality temperature measurement, relative humidity, air movement, or HVAC, which we talked about ventilations, and CO2, carbon monoxide, and the particle volume. So these are some additional equipment, some handheld equipment which are used in some factories, some offices, or some campus there, find out what type of things are happening. Or some engineering college students, those who can't buy a bigger equipment, or who are stepping into this research of aerosols, they use this type of portable equipment to find out what the type of aerosols are, what type of pollutants are. quickly.
Much, Mr. Nishant. A very nice presentation, and I think you have cooperated SI instruments also with measurement science. Very interesting. I have a few questions.
Yes, sir.
The important question is, you said that you are measuring the interval size and number concentration at CH, right?
Yes, sir. Yeah.
So, when we measure the particle concentration, CH, what's the height? I mean, from the.
So it's around 3,000 feet. So it's the Khardungla Pass is there, so close to that height. Little closer and little down to that, around 3,000 feet. So it's a military base, so we don't have much of data to share, but it's.
So, but it's seems that is sometimes or most of the times is measurement is going in the free troposphere, right?
Yeah.
Right. So you don't have any data to show or?
So we can't show that data. I have the data for last 2 years because instrument is installed before COVID there. So we have a data for more than 2 years. But the problem is that it's a military data, so we are not allowed to share or show any data.
So Indian military is using this.
So this is handled by this unit, DRDA unit in Chandigarh.
Okay.
Earlier its name was SASE, Snow and Avalanche Studies. So now they have converted to DGRMSC. So they are handling this particular station and they are using this. They have installed some weather stations and other monitors. Basically, they are trying to understand how this aerosol is affecting, and because of that, how avalanches are getting more as compared to this. So since I've been to their station, they keep data that in particular year, how many avalanches are going. So they keep and then suddenly there is an increase in avalanches. So their understanding is that aerosol is also one of the reason because of these avalanches. Because aerosol, these are black particles, they settle on the snow, then they capture more of the sunlight. And because of sunlight, it becomes more, start melting. Coming in avalanches. So they're trying to understand those things.
They have a complete monitoring station, right?
Not complete, sir. They since it's a military, they have a very limited resources, but they have allotted one room where we have installed this instrument. Some other equipment.
So, and you said that about the mobile van, right?
Yes, sir.
That mobile van you have established here or it's under the TSI?
No, sir, not under TSI, but like people do inquire. So since we are in this field and we know how the instruments are, we need to take care of the equipments actually. So we help them to design the vents, like how the instrument should be kept, how the inlet should be kept. The inlet should be also connected. It's not like we just put some pipe there. So what type of instrument, what type of things you need to do. So those things we help them, and then end users can procure it.
So any other questions from the audience? We have some questions from
Yes.
Okay, so I thank Mr. Nishant again for his presentation. And now we have our next presentation. From Vasti, but he's somewhere coming, so we'll shift it at the last. I invite Mr. Ishigawa from the India Private Limited. Please.
Yeah, sure. Just share the volume. This is you say.
Okay. Thank you. Thank you very much. Hi again. I'm Kyohei Nishizawa from Horiba Limited, Japan. And I'm doing the product manager for one of the ambient quality monitoring instruments, which is called PX375. That's a semi-continuous ambient metal monitor, which is usually commonly used for pollution source analysis. Let me first say, introduce who we are, company Horiba. We're based in Japan, having a global offices worldwide. We are founded in 1945. And we have globally close to 8,000 employees, and our chairman is now at Horiba. And we have 5 business segments areas. One is automotive, particularly for vehicle development, R&D, process environmental. This is where I'm from. Medical, semiconductor, scientific. And for those 5 business areas, we are utilizing the core technologies of the company, which are, for example, optical filters, dispersive spectroscopy, FTIR detectors, pressure sensing, and so on. And now I want to move on to the Horiba India Private Limited introduction. As a Horiba India, we already had a business with our partners in India, but officially we started we founded the corporation as Horiba India in 2006, and over the past a decade, we've grown up to where we are now. Our head office in India is based in Delhi, and we have an advanced technical center in Pune. And this is those are the facilities we have at the technical center of Pune. Lastly, in the introduction of our company, this is an example of the mobile air quality monitoring stations we designed and built in India. For this mobile AQMS, we also integrate the product PX375 that I want to explain today, which does semi-continuous monitoring of PM mass concentration and also multiple metal concentration analysis. Not just the PM, but also gaseous elements such as NOx, SO2, carbon monoxide, carbon dioxide, ammonia, TC, and so on. We take care of all the integration designing in the factory facility of Pune. Thank you. So that was the basic general introduction of Horiba. And now I want to start talk about the main topic of today, semi-continuous ambient metal monitor, PX375, and also the pollution source analysis. The agenda flows like this. I will explain the benefits of ambient metal monitor, and then I will briefly explain what is the product PX375. And lastly, and the most importantly, I want to share my experience of research case studies in Japan, globally, both. So firstly, I think you guys will know about what PM2.5 is a very tiny particles in the ambient. But if you take a closer look at the PM, they actually look different. And depending on the pollution source, their size is different. Their shape is different. And also the component of particles is also different. And now, why we, worry about develop the product particularly for ambient metal monitoring. The reason is metals can work as trace elements in ambient to identify or make assumption where is the pollution generation source, which is called source apportionment or source pollution source analysis. Because metal elements, they are hard to change composition over the transportation in ambient due to chemical reaction. That's a big advantage of monitoring ambient metals. And on the right side of the slide, I am writing an example of pollution analysis method, which is chemical mass balance, CMB for short. This is a simplified image, but based on the components that you have in your sample PM, you can make an assumption of where the pollution is coming from. For example, if we have aluminum, calcium, C, titanium, maybe the pollution source is mainly soil, but if there is a great proportion of iron included, now you have a different story, and you need to look around also raw dust too. That's a very basic approach of pollution source analysis. So the solution, the product that we provide for such field is PX375. What this instrument does is it takes care of the sampling of the PM. It measures PM mass concentration with a beta ray attenuation technology. And it also does metal concentration analysis with XRF technology. That's all completed in one unit on site. Nextly, it's automatic and near real-time analysis. So as discussed earlier, also today, since it's automated, human errors or measurement biases are gone. And continuous monitor visualizes time trend that helps researchers to smooth verification of hypothesis. I'll talk much more about those later. This is an example of detectable metals with the PX375. And on the right side of the slide, I listed the LDL for some of the elements. Basically, if you have longer analysis time, X-ray irradiation time, of course, you have a better LDL. I think it's since this instrument composes of two technologies, XRF and beta ray attenuation. Sometimes it's hard for people to imagine how it works. So this is the internal image. From the sampling head, we inhale the sample particle, and the filter tape will capture. And at the same position, mass concentration analysis completed with the beta ray attenuation technology. And now with the roller, with the orange bar, filter tape is advanced next to the X-ray analysis position. in this procedure, the measurement for two different parameter is completed. We actually have a booth and the actual instrument that in the other building. So if you have time later, please visit us and have a chat there. So what is good about our PX375? The original motivation for us to develop the product was challenges for researchers doing pollution analysis. Like 10 years ago, all the measurement of all the metal measurement of PM was only by a manual method, which starts from sampling at the site, going over pre-treatment process, and then you can finally carry out lab analysis. The difficulty about this is since it's an expert analysis, of course, labor cost is high, and it requires long time from sampling to measurement result acquisition. Typically takes 2 weeks. It's also difficult to grasp time trend, like a quick search of particular elements with high frequency. So those were the challenges. And now with automated XRF and also battery attenuation technology instruments, you can embrace the benefits such as written here. And I want to explain one by one. For example, for time resolution, you can now analyze the pollution influence by time of day. If for manual method, it's usually 24-hour average, so you can't grasp the change in the daytime. For example, during rush hour, of course, more vehicles are running, so getting more influence of vehicles. But if it's averaged, you can't see the sharp peak in a particular short time period. But since we are providing shortest 30 minutes measurement frequency, you can also see a spike in time in short time. Pre-treatment, since it's automated, of course, you don't need to do it. So it's easy to install now, and you can reduce the man hours required for analysis. Since it's automated, you can generate a lot more data. That's very important when you try to do a pollution analysis. Since if you only have limited number of measurement data, of course, the reliability gets lower. Lastly, but not the least, promptness is important. Our instrument PX375 will get back to you with the measurement data in 1 hour. But as I mentioned earlier, if it's a lab analysis, you need to wait for at least 1 or 2 weeks. So by having a quick measurement completion, you can carry out smooth verification of pollution source hypothesis and so on. And if you want to do like immediate countermeasures, you can also implement that. All right, so from here, I want to have some time and look at the measurement examples and the case studies. This is the measurement that I took from the Ministry of Environment Japan. They are using ICP-MS for ambient metal analysis and also using PX375. So I took the measurement data and put it in the same time scale. I think this is visualizing the key points of continuous measurement. The upper one is a PX, the bottom one is ICP-MS. As you're seeing, ICP-MS is 1 day average, and for PX, for this case, is three-hour average. And you can only see the outbreak of titanium in a particular time, but it's not seen in manual analysis measurement data. Right. So utilizing such features, those are the examples of the applications. For example, one of them is advanced air quality monitoring stations, which is sometimes also called super station, and also pollution source analysis, baseline monitoring of plants, like petrochemical plants, refineries, and so on, steel plant as well. Some customers prefer to do direct stack metal monitoring as well. We can also handle this requirement by the knowledge and experience of process or stack measurement. Marine research, we also have experience with mobile air quality station with the PX375. And finally, geographical mapping of pollution. Right. I already referred to this case earlier, but Ministry of Environment Japan is also using this instrument. In Japan, the PM 2.5 level has been improved a lot over the past decades, but there is still areas where environmental standard is not well achieved, particularly for a short time period. So the government needed to take further actions to improve the situation. But the thing is, since they were only doing manual analysis, they didn't have a clue how to further improve. That was the first motivation why they wanted to think about purchasing the instrument. So right now we have in Japan we have close to 2,000 AQMS for gases, components, and PM. Now they installed 4 units of PX375 so that they can look at the breakdown components of metals and try to identify what is the cause of it, trying to figure out the countermeasures to improve it. This is a measurement result. As you can see, the R square, the correlation is pretty good when you compare the measurement data of PX375 with the manual analysis method. Another case is wide area pollution analysis research. In this research, they used the PM 2.5 concentration data and also metal concentration information and a parameter called oxidative ratio, OR. So the situation was, as I mentioned, when the PM concentration gets high in Japan, we suspect the pollution is coming from overseas sometimes. And when pollution is coming from overseas, usually the influence of coal-firing facilities gets greater than usual. That's why that's a typical assumption of us, but we didn't have confidence. So the researchers did one study here. In this graph, the black chart is showing PM 2.5 concentration time trend, and then the red one is showing lead zinc ratio. This is simply lead concentration divided by zinc. Zinc is most of the cases stable. When you are getting more influence of lead, this ratio gets greater. So this is an indicator to tell you when you are getting more influence of coal combustion pollution. Okay. If you look at the peak of PB zinc ratio, the gray area, actually PM 2.5 concentration is not going high, which means for this time duration, coal firing wasn't really the cause of PM 2.5 concentration increase. Okay. Now, to further investigate the relation, we applied the concept, the parameter called OR. It's an oxidative ratio. It's oxygen divided by carbon dioxide. How we use it? Depending on depending on the fuel that you use for facilities, this ratio again varies. For example, if you're getting the influence of LNG, this ratio gets closer to 1.95. But if you're getting influence of coal mainly, the indicator gets closer to 1.17. That's how you utilize this parameter. And we applied this method for the two peak in this time period. The first one is showing 1.1, and the second one is showing 1.58. So maybe the second one is getting more influence of LPG or LNG, not the coal influence probably. But the first one is close to 1.17. So maybe we are still getting the influence of the coal for the first peak, even though PB zinc ratio is not increasing. The assumption we can make here is PB is included in the raw materials of coal, but it's not always the same. Sometimes it can be lower as an impurity. So we have to look at each breakdown of the causes and try to finalize the hypothesis. The next one is mercury pollution analysis. Mercury, as everyone knows, is hazardous to human health. That's why it always gets attention of people, researchers. If you look at the mercury, they exist in different types. Elemental mercury, in other words, metal mercury, oxidized mercury, or particulate mercury. But the last two forms, they easily drop with rain. But metal mercury stays in ambient for a long time. That's why this is the metal mercury is the main concern. And even if you look at the composition of three types, metal mercury is taking up most of it. Ministry of Environment Japan is actually already doing mercury monitoring. They are also monitoring mercury concentration continuously 16 times a day. But they are not doing continuous monitoring for other metals. Why I'm picking up this point is if you have continuous mercury measurement data together with continuous measurement data of other elements, you can do a better pollution source analysis. I'm going to explain how it works. So I listed the possible pollution sources of mercury on the left side: coal firing facilities, cement facility, incinerator, sound, heavy or combustion facility. And each facility has a representative indicator. For example, earlier I explained the coal combustion facility. They have lead as a representative indicator. As likewise, other pollution sources also they have representative indicators. So applying this theory, please look at the slide on the right side. The red chart is mercury concentration. Yellow chart is again Pb lead zinc ratio. And green chart, it's a calcium concentration trend. All right. And obviously you can understand during this time period, we had two peaks of mercury concentration. But for each peak, for the first one, lead zinc ratio is showing correlation. But for the second one, lead zinc ratio is not a synchronizing, but calcium concentration is showing higher correlation. So the assumption you can make here is for the first peak of mercury concentration, right here, maybe this is influenced by the coal combustion facility because lead zinc ratio is representative indicator for coal. And for the second one, right here, maybe for this time period, you're getting more influence of cement-related facility. So such wise, not just the target elements that you want to monitor, but if you are monitoring other metal concentration continuously, that will help you to do pollution analysis. Given another example, baseline monitoring. This is a common case. You have industrial area and residence area nearby. We are also doing geographical mapping. And if you look at the PM, this one, PM is coming from anywhere. Sulfur is also coming from anywhere because it's commonly included in sand. But if you look at the lead iron chart, laser chart, you can see it's coming from one particular direction. This is the location where iron steel manufacturing plant is located, and they use coal as fuel. I guess that makes sense for you now. Another pollution source analysis method is PMF. That's a short term for positive matrix factorization. That provides you contamination generation contribution ratio of different types of generation sources. But the thing is, you have to provide the software the adequate amount of data for as many measurement objectives as possible to obtain reliable data. So this is good, but it doesn't apply all the time. There's also a limitation. We did the case study with PX375, AP370. This is our different product line for gaseous component monitoring in the complete air quality monitoring station. And this is the results. What we get is basically categories of the pollution source. And I'm just listing up the two categories here. The first one, you can see the characters is small, but CO and SO2 are the distinct indicators for the pollution source, which is vehicles or all combustion facilities. And down below, you are seeing the time trend of pollution contribution of a category 1. In other words, oil combustion. For the category 2, factor 2, copper concentration is a distinct indicator, as you're seeing. Okay. This pollution source is mainly mining or smelting of copper. So you can see at the bottom, that's another time trend chart for pollution contribution of copper mining smelting. You can see a specific outbreak of the contribution at the specific time only. So not always polluting, but maybe there was something wrong with the facility at the specific time. That will lead you to take very concrete countermeasures. All right. So as I mentioned, PMF you can't always apply because there's a limitation. So sometimes you have to also think about how to do pollution analysis, try to identify the pollution source with the limited available measurement data. This is also one of the case. This is showing the concentration of iron. That's a yellow chart. And the blue bar, that's a wind speed. Looking at this chart, the one assumption you can make is the concentration of iron is getting high only when a wind blows at higher than certain speed, like 3.5 meters per minute. So if that's true, if you can reduce the wind speed, you can reduce the amount of iron pollution at a specific location. One example of the countermeasures is to, for example, build a fence. Another example is looking at the trend chart of representative indicators. This is the case for sand. For sand, aluminum, silicon, potassium, calcium, those are the representative indicators. If you look at this chart, you can see all the elements are correlating. But I wrote in the gray area example of trace elements representative for different kinds of pollution source. Such ways you can utilize same way. I think I have two more. Pollution control analysis by data mining. We are right now doing one project in Japan. We monitor the metal coming out from facility stuff, and we are also monitoring air metals nearby the plant. Do data analysis, trying to find the relation of the air quality in particular location and operation of the plant, so that you can finally understand how you can optimize the process control to reduce the pollution influence. This is more towards the post measurement actions for private sectors. Yeah. Likewise, not just in India, but globally, we are doing a lot of projects. But in India also, we did a pilot study with CSE in 2019. And we are also, not just this project, but we are also doing some of parallel projects with other academic organizations. So to wrap up my session, the PX375, the features are sampling PM mass concentration analysis, metal concentration analysis all done with one unit on site. It's automatic near real-time analysis. Since it's continuous, you can have a very good visualization of measurement data in time trend. And finally, but this is a really a key point for me, Horiba is happy to further discuss with you about semiconductors ambient stuck metal monitoring and pollution source analysis method, as I explained today, and post-measurement actions. Not only limited to those, but also I want to discuss data visualization and data analysis too. That's it from my presentation. Thank you very much. Yes, sir.
Thank you, Shidawa-san, for your nice presentation.
Thank you.
And I think you have covered nicely about your company, the product, and also research, especially source approximate studies. These are very, very interesting. I have, of course, a few questions. Okay. So first of all, about PX375 instrument. As I understand that it can measure most of the elements which can be detected by XRF, right?
Right.
So in India, in national ambient air quality, whatever we are, modeling, it is implemented in 2009. And in that, we have three pattern parameters, arsenic, nickel, and lead. So I believe that all three can be determined using your instrument, right?
Yes, yes.
So, and also because in our standard, we haven't mentioned that whether we should, measure this arsenic, nickel, and lead in PM 2.5 or PM 10. But I believe that in your instrument, we can use the PM 10.
Yes,
Next rate also, right?
we have a lot of project we've done to measure arsenic, lead, and what was the other one? The element?
Nickel, arsenic, and lead.
Oh, yeah. We have experience with these, and also we have the LDL data for those elements.
Nice, right, very good. And one more question about because you said that oxidation potential of
Right.
aerosols.
Mhm.
You use delta value of oxygen divided by delta value of carbon dioxide, right?
Carbon dioxide, yes.
So how you measure this?
We used our product called APCA 370. That's ambient CO2 monitor.
So in this, it's a Horiba instrument.
Yes, sorry, I didn't mention, but we use different instrument of Horiba for OR. Yes, it can be measured with the PX375.
Yeah. So and one more question about in Japan. Actually, I have been in Japan for several years, so I know that the concentration what you have shown it's just like most of the time it's remained around 10 micrograms per meter.
Right.
And sometimes, of course, 25 or 30 micrograms.
Yes.
But in India, it's not possible because we have a climatic condition, different climatic condition. So, in November and December, especially when we have a biomass running from our neighbor states, then particle concentration, 2.5 concentration becomes more than even 500 microgram per meter. Right? So in that case, if we have a 30 minutes interval, I believe, because XRF measures the concentration layer by layer, right?
Right.
So if you have too much concentration, so can we reduce the time interval like 15 minutes or 10 minutes?
15 minutes, yes. Actually, the PX375 equips the function if the layer is too thick. It automatically advances the filter tape.
All right.
Yes. And finally combine the two measurement data to obtain one measurement data. That's how we are handling the issue. Yes.
So, of course, so 30 minutes means not the one time, maybe several times.
Yes.
But you will see the 30 minutes interval, right?
Yes.
Very good. So that's all from my side. So if anybody else
having some questions? Yeah, please.
You have shown your PX 375, very nice instrument with that method of the XRF as well as ICP-MS. What I understand that both techniques require the calibration. The help of CRM are known materials, but we want to very much eager to know where how you are using your instrument continuous monitoring, particularly the calibration.
For calibration.
How you are going to calibrate this?
Okay,
Because as far as XRF concerned, it needs calibration. As far as MS is very much required for calibration.
Okay.
So what material, which one material you are going to calibrate your equipment? Please find it.
For the XRF calibration, we use the standard material it depends on the case, it depends on the elements that you want to measure. But if the material is available, we use the standard material from list.
Yeah.
Yeah.
So you are using the standard material for calibration of
Yes.
XRF as
Yes.
well as the ICP, MS.
As well.
Because it is hyphenated, na?
Mm-mm.
You are going to hyphenate the two techniques, that is ICP, XRF along with the MS.
Right. Yes, the NIST is I believe NIST is producing the standard materials using ICP-MS to verify the body. It's in that line. I think the answer is yes.
Means your equipment requires calibration.
Oh, yes. Yes. Thank you very much.
Yeah, I can answer his questions. Actually, he's asking for the XRF we have in PX 375 for the calibration. So of course, as you said, that NIST providing the certified reference material
Right.
for calibration, and you are using it.
Yes.
But on the same time, he's also asking about the ICP-MS. I think you are not using the MS technique here, right? The one
Which was sorry?
mass spectrometer.
No.
So it's just the other instrument is the beta attenuation. Yeah, for the mass concentration measurement, and the other one is XRF, metal concentration measurements.
Okay.
Yeah.
That needs
Yeah,
calibration.
yeah, of course.
Right.
Okay, so any other questions? Do we have any questions from the online participants? No. Okay. All right. So, Nishiyama-san, thank you very much.
Thank you very much.
Thank you. So now we have a last presentation from Mr. Lee Sang-min from Cantech Corporation. So, Mr. Lee, please.
Hello, my name is Eric. I'm a sales manager in Cantech in South Korea. Before presentation, first of all, thank you for giving me a chance to introduce our company and products. to you guys. Once again, thank you. Okay, from now on, let me introduce our company briefly. Kentek was established on 2008, and since then exported $1.5 million to China, and we have acquired the US EPA certification related to red type analyzers for the first time in Korea. And we are the company 25 years experience for air quality monitoring system. And we are made up of 23 employees, and we are doing our best to manufacture high quality for our advertisements. We are manufacturing products as below: red type analyzers and port type analyzers and particulate matter analyzers and the data logo calibration system and so on. These are the certifications we have acquired for gas analyzers and particulate analyzers. This is verifying that our technology and our products are very good quality and high performances. Our business area is air pollution, yellow dusts, indoor air quality monitoring, ultrafine dust monitoring in subway. When you take a look at the installation cases, we have installed the air pollution measurement network system in the whole country of South Korea. And we installed the yellow dust monitoring network system at China-Korea survey travel route. And we installed the indoor air quality monitoring network system in Incheon airports and the ultrafine dust monitoring network system in the subway at 270 stations. All measurement results are sent to Air Korea and in their web, and it's being displayed in real time. As you can see on the right side of this chart, you can find their measures about PM10, PM2.5, and SO to CO, all three NOx in real time. And these data values are being opened to the public. We are selling the products not only in domestic but also overseas, such as India, China, Vietnam, and now we are selling the products to Colombia, Chile as well. We are expanding the territories now. Okay, let's move on to the products. This is air quality monitoring station. This AQMS is made up of particulate matter and data logger calibration systems and gas analyzers and meteorological sensor to measure environments of measuring station and the air conditioning system and the computer to get the data and monitor the data. All these products are supplied by Kentek at one time, including measuring station. This is air quality monitoring vehicle. This AQMV is made up of red type gas analyzers, particulate matter analyzers, and meteorological sensor and data acquisition system. This is useful for users to move measurement sites from spot to spot. They will measure very simply, easily, and conveniently. This is our product lineup. We are manufacturing red type gas analyzers and calibration systems and the particulate matter analyzers and data collecting system. Let's take a look at the products more in detail. This is our gas analyzers. Gas analyzers are made up of red type analyzer and port type analyzers. These analyzers are classified by SOT analyzer and MX analyzer and steel analyzer, OT analyzer. When you take a look at the measurement method more in detail, SOT analyzer is using UV fluorescence method, and the NX is the chemiluminescence method, and the CO is non-dispersive infrared method, and the O3 uses the UV absorption method. More of these analyzers, breakdown analyzers, have acquired the US EPA certification. As you know, US EPA certification is the standard of these analyzers in this field. And this analyzer is equipped with LCD touch screen so the user can operate it easily and maximize its visual imaging. And to prevent the addition of a specimen, splashing tube is made of a special coating material is used to improve minimum detection and precision. This is the prototype analyzers. Prototype analyzers have same kind, same function, same quality as the rectangle analyzers, and is useful for user to move medical location very easily and simply. And this is brand new for the gas analyzers. This for gas analyzers is screen is bigger than before, 5 inch to 7 inch, and the software is upgraded more so that user can more easily be operated easily than before. And this is calibration system. Calibration system is made up of multi-gas calibrator, two air generator, and the ocean standard reference parameter. Calibration system is for calibrating the gas analyzers such as SO2, NOx, or 3CO. And the ocean standard reference parameter is able to be used for calibration of the O3 generator in a multi-gas calibrator and the O3 analyzer and generator as well. This is a brand new system, IoT air monitoring system. User can choose the measurement item up to 6, and they are able to monitor the data at the same time and using web, such as using the cell phone and the telepiece. This is the particulate matter analyzers. This is the analyzer that measures the particulate matter using battery absorption method. These analyzers are made up of metric 610, 600, 600 LB. 610 is the rectangle analyzer, and the 600, 600 LB are prototype analyzers. Two of these analyzers, 610 and 600, are for indoor-outdoor measurements. The other one is for indoor measurements, and it's built in the pump inside of an analyzer box. And this inlet part, as you can see, this inlet part was designed by our technology team to meet the US EPA standard, and we insert it after authorized the test. And this analyzer is available for gel correction every hour when required, and is equipped with LCD touch screen so the user can operate it easily and maximize his visual images as well. This is the sequential particulate sampler. This analyzer is available for 18 47 millimeter filter cassette successively, and the user can check the device operation events using LTE modem remotely, remote controlling system. And this is the black carbon aerosol analyzer. This analyzer uses optical attenuation method, and this black carbon is analyzed at 7 bands wavelengths in 370 to 950 nanometer. And this is data collecting system. We are manufacturing the data logger to get the data of analyzers and to communicate with main server. And this is a wireless terminal monitoring display system. In order for us to get the monitor the data remotely, we are manufacturing the wireless terminal. Using various terminal, we have been monitoring the data and getting shown the data on display in real time so that the user can check the current solution status very fast. So we have installed display systems at insurance survey 48 station platforms and the 150 waiting room and Q4 Gold Line 12 station platforms and the 24 waiting room in South Korea. Okay, thank you. This is all I have prepared today to you guys very briefly, our brothers. Thank you for listening. And if you have any other questions, please let us know and to come to our contact booth in Apache site building. Thank you.
कितना नंबर है गुप्ता जी को बुलाना था कितना नंबर लिखा है
Okay, no question. Yes, good use the mic. Okay, I'm okay.
Oh, yeah. I think it's working. Not, then also I can, yeah, I think, yeah, it's okay. So, thank you very much, Eric, first.
You're welcome.
Yeah, you have mentioned about the Cantech incorporation nicely and shown the product and the series of the product what you have developed so far. So I have just one query about your black carbon.
बंदे को रहना होगा ना माइक वाइक देने के लिए
I saw first time. You have some comparison data for black carbon measurements. One round that was still under.
Actually, please understand, it is of course for me to explain the black carbon more in detail. It's very difficult for me, so I'll email you the data or something you want.
Yeah, it's okay, just one query, and the other one is you have also developed SRP.
SRP.
Yeah, the ozone standard, right? As NMI or interest is very clear that you need this kind of instruments, especially. So, did you have any comparison for this? Maybe you can show later on and think about it. The intercomparison. Yes, of course. Yeah.
Data?
Yeah.
Data? Yeah. About the data?
Yeah,
Yeah.
Intercomparison, right? Yeah, it's okay.
Okay, so
Yeah.
now based on the freeze, you know, like standard relatively project, but we have the reference of all the data from the freeze. So we have already a prepared data, but later we have to prepare the information.
Yeah.
All data is from the freeze.
Thank you. So do you have any questions from participants?
No, there is no question.
No questions. Here, if you have some questions. Thank you. Eric.
Okay, thank you.
Okay, so we are on time. We are finishing it at 1 o'clock. So first of all, I would like to thank our speakers, Dr. Harsh, Mr. Nishant, Mr. Prakash, but he was not here because he stuck somewhere. Nishiyama-san, Mr. Lee Sang-min. So thank you very much for your participation, your time, and also sponsoring pre-AdMet and AdMet International AdMet Conference. Thank you very much. And I also thank on behalf of MSI, Meteorology Society of India, and Director CSIR NP for your time, and you came here, and sponsored this conference. So thank you all the participants, and also the participants those are watching or listening us in online mode. So thank you very much. And because we have a final closing of this International AdMet Conference on 26th at 4 o'clock. So and that in the final closing ceremony, we have our invited guest and also our director. So I request you to please join this closing ceremony. Then we have some souvenir for you. So all the speakers you can get from our director. So I invite you in the closing ceremony for your welcome and also that souvenir. So please join us. And now I invite you all for lunch. We have outside in Dr. E.R. Verma lawn. We have a lunch in front of your booths. So please join us. Thank you very much for your time and cooperation. Thank you. So I finish the session.